LangGraph's asynchronous data persistence layer implements a structured key-value interface through AsyncPostgresStore, enabling durable storage and retrieval of application state within a relational backend. This component abstracts PostgreSQL interactions behind a clean async API, exposing methods like aput and aget for atomic operations on hierarchical keys. We'll examine how the store initializes via from constring, establishes its schema through the mandatory setup migration step, and then demonstrates basic CRUD patterns by storing and fetching a user preference object under a composite key. The upcoming code snippet reveals this complete initialization to operation sequence, highlighting the store's role as a foundational persistence primitive.
From LangGraph, store, Postgres import AsyncPostgresStore. Constring equals PostgreSQL //user, pass at localhost 5432/db name. Async with AsyncPostgresStore. From constring as store. Await store setup hash run migrations. Done once. Hash store and retrieve data. Await store aput users. 123 prefs theme dark. Item equals await store aget users. 123 prefs.
This code demonstrates the basic usage of AsyncPostgresStore for asynchronous data storage and retrieval in PostgreSQL. The pattern follows a context manager approach, where the store is instantiated from a connection string using from constring, then initialized with setup to create necessary tables and migrations. This one-time setup ensures the database schema is ready before operations begin. Data operations use aput and aget methods, which follow a key-value pattern with composite keys. Here, users, 123, acts as the primary key, while prefs serves as a secondary key for organizing related data. This two-tiered key structure allows for hierarchical data organization within the same store, useful for scenarios like user preferences or session management. The asynchronous design is particularly valuable for I/O-bound operations, preventing blocking during database interactions. The explicit setup call, while requiring manual invocation, provides clear control over schema initialization timing. This approach trades some convenience for predictability, ensuring migrations run exactly once when intended rather than implicitly on first use. Let's break it down.
From LangGraph, store, Postgres import AsyncPostgresStore.
Imports the AsyncPostgresStore class from the LangGraph, store, Postgres module, which provides asynchronous PostgreSQL storage capabilities for checkpoints in LangGraph applications.
Constring equals PostgreSQL //user, pass at localhost 5432/db name.
Assigns a PostgreSQL connection string to the variable constring using the format PostgreSQL //user, pass at localhost 5432/db name, which specifies the database type, authentication credentials, host, port, and database name for establishing a connection.
Async with AsyncPostgresStore. From constring as store.
Creates an asynchronous context manager for a Postgres store instance using the provided connection string. The AsyncPostgresStore from constring method instantiates the store, and the async with statement ensures proper resource management, automatically handling setup and teardown of the database connection. The store variable will be available within the context block for operations like storing checkpoints.
Await store setup hash run migrations. Done once.
Asynchronously calls the setup method on the store object to initialize the database by creating required tables and running migrations. This operation must be executed once before using the store and is performed asynchronously.
Hash store and retrieve data. Await store aput users. 123 prefs, theme, dark. Item equals await store, aget users. 123 prefs.
Asynchronously stores user preferences data in a key value store using a composite key. The first line writes a dictionary containing theme preferences to the path users, 123 with the key prefs. The second line retrieves the stored preferences from the same location, demonstrating basic async get set operations on structured data. The AsyncPostgresStore provides a clean async interface for hierarchical key value storage in PostgreSQL, abstracting away direct database interactions. The workflow begins with connection setup via from constring, followed by an explicit setup call to initialize the schema, a design choice that prioritizes predictability over implicit migrations. Within the async context, aput and aget enable atomic operations on composite keys like users, 123, and secondary keys like prefs, creating a natural hierarchy for structured data. This two-tiered key system allows flexible organization while maintaining atomicity, making it ideal for state management in async applications. The async await pattern ensures non-blocking I/O, crucial for performance in database-heavy workflows.
The store migrates your dark theme into existence, then dissolves it upon request.